Okay, we're going to go through properties of kites today. I'm not going to spend a ton of time on this because I don't think necessarily you guys even need a ton of time on this. There looks like a lot of properties going on here. It looks like there's quite a bit. It's got 3 bullet points over there, but typically what I would say for kites is really just 2 things. Number 1 is that these diagonals here are perpendicular to each other. If you've ever put together a kite, which by the way, maybe I should have started there. A kite is, something that you fly outside, and typically a lot of them look like this shape, but it's actually a geometrical figure as well. But if you have ever put one of those together and flew it outside, those wooden dowels that come in those cheap packages of kites, you have to put those together in a perpendicular manner. So both of those diagonals would be perpendicular to each other. That's one of the main features. Diagonals are perpendicular, it says right there. And then these other ones, there's a bunch of stuff going on here. But if you just remember that kites are symmetrical, everything else kind of falls into place. So I'm not going to be able to turn my screen on its side really. But if I scroll down, potentially, oh, they don't even give me one that's standing upright like that. It's symmetrical on the obvious line, here we go, this line here. So everything on one side is exactly the same as everything on the other side, meaning this is congruent to this is congruent to this. You have this full angle here that's congruent to this full angle. That's basically everything that it's mentioning right here. There's other things that are true as well, though. For example, if I erase this, I'm saying everything is symmetrical. So even if I found this angle, let me zoom in even, like just to the diagonal, this angle here is congruent to this angle here. And this angle here is congruent to this angle here. This one down here is congruent to this one right here. And then lastly, this one and this one. If you see what I'm saying there, like everything is symmetrical on one half to the other. So that should help you with all of these questions down on the bottom. Our main properties are that the diagonals are perpendicular, and then after that, it's just symmetry. You're just looking over at the other side to figure out what the answer is. For the first one, it's not giving us either B or D. We're asked to find them ourselves, but I do know that a 4-sided shape has 360 degrees inside of it. So if I subtracted off this one and divided by 2, you could get those. I'm not going to go through that, but I will give you 30 seconds or less here to figure out what those 2 angles are. Go. Okay, hopefully we have it by now. If this is 71 and this still adds up to 360 and this is 82, then you know this is 82 and you could find K by subtracting again. Go ahead. As we were mentioning before, even these angles are congruent. So if that one's 37, I'm assuming over here it's asking for TRQ or QRT, I guess. So that would be 37 for that one. And then we have, looks like an angle that's made by the diagonals. So PTQ would be 90 degrees. And then PQT is this top angle right there. But if you know that this is a 90-degree angle, you could subtract because you've got a triangle, and that would leave this to be 53 degrees. Number 4. All right. We had this is 59. I'm going to quickly just go over here and write 59 in there. And so if we go through this, we have GDE, which is the entire thing. I guess you would just add those 2 together to get 118. And then DEH, oh yeah, using this 90-degree angle, you would find that. It looks like 31. This side is also 31. I believe that's what both of these are asking. Not going to go through too many more, but as you can see, it's asking for every single piece of these triangles. I'm not even going to go through these right now, because if you know that these are 90 degrees and you know that they're symmetrical, this shouldn't be an issue to figure out the rest of those. You're just going to use triangles to find them. So let's see what else we got. Number 7, it says WX is 14 and WR is 8. Using, this is a 90-degree angle, we're going to go back to that Pythagorean theorem. And I don't think this is super difficult to do, but I do know that there are some people on quizzes and tests that forget about the Pythagorean theorem. And so this is just a little reminder that you'll have to do that. Looks like a similar question there. I'll let you try that one on your own on the homework. I don't think we have too much that I'm going to talk through there. We've got more perpendicular Pythagorean theorem questions. This one I'm not going to talk about too much either, but it looks like this would be congruent or equal to that. So you just set them equal to each other because they are congruent to each other, because it's symmetrical right down the middle here. And then same thing for the next one, and number 13 is a little bit different. So if that's 109, this would be 109 up here. And it looks like you'd have to add those together and set them equal to 180 or to 360 since it's a 4-sided. I think that's about all I'm going to go through on this. So good luck on the homework. It is posted online. That would be the next page in the notes.